We shall see GATE 2020 set 1 question number 31. So this is GATE 2020 set 1 question number 31. So this question goes like a rigid massless rod of length L. Okay, so this is a massless rod which has total length AB is equal to L, is connected to a disc pulley of mass M. So this is disc of mass M and radius L by 4. So radius equal to L by 4 through a frictionless revolute joint. The other end of the rod is attached to the wall through a frictionless hinge. So this is a hinge. Spring of stiffness 2K is attached to the rod at its midspan. So this is stiffness 2K attached to the rod at its midspan. An inextensible rope passes over half of the disc periphery and is securely tied to a spring of stiffness K at point C as shown in the figure. There is no slip between the rope and the pulley. The system is in static equilibrium in the configuration shown in the figure and the rope is always taut. Neglecting the influence of gravity, the natural frequency of the system for small amplitude vibration. Okay, so they are just giving a small amplitude vibration. So what is the angular frequency? How will it move up and down? So before that, let me give some basic knowledge before we go ahead with this. Let's assume we have the disc like this, okay, and we have a spring like this, and this is one of the previous year's GATE question also. I hope many people would be aware of it. So what will we do is actually we'll make this particular disc. We assume that we try to pull this mass and leave it so that it comes up with some angular frequency. And the question was like, what will be the angular frequency? While calculating this, we'll just go ahead with this is radius r, this is theta. Let it be the x distance it has moved. Okay, so that would be the x distance over here also. The disk moment will be the x. Okay, so that would be the translation moment of this mass m also. So this x can be written as r theta, right? So x is r theta. So this is the exact thing which we need to learn over here. Okay, so once this is done, let us take this sum now. So this is one concept which we need to know before we go ahead with this. So let me draw this diagram over here. So first we have a pulley over here, we have a straight line, we have a disc, we have a spring, and then we have a fixed base. Okay, then we have a massless rod as given in the question. This is a massless rod. We have a spring of 2K. Okay, then we have disc mass M. So disc mass M. Okay, so no need to write it over here, it's already given in the question itself. So we'll just write what was required for us. And spring stiffness is required for sure. This is 2K and this is K. So L by 2 is required. The distance is L by 2 and L by 2. Over here this is gonna be L by 2 and this is gonna be L by 2 up to this point. Okay, so radius is L by 4. So now what will we do is we'll try to move this a little bit so that it comes and it goes like this. Okay, now in this, if you could see, let's assume the disc comes over here at this point now. Okay, so the distance moved this center point to this center point, let's assume this to be the x. Okay, so let us that is the x. So now this spring would have moved down. Okay, that is x, and it has made a angular rotation also. Okay, so while moving down it has made a angular rotation also, as well as we have one more spring over here. Okay, so which has moved down, so which is this. Okay, which is 2K. So this is the configuration. So from this we can know that, so let's take this particular distance is y, so this is x, obviously this should be theta. So now let's try to solve this. So y should be equal to L by 2 theta. So because this is L by 2, this is theta, so we'll have like this, this is L by 2. Okay, so this is theta and this is y. So now if you could take y is equal to L by 2 theta. Likewise if you could take for x, okay, so if you take for x is equal to L theta. Now if I'm going to take y is equal to substituting theta, okay, theta as x by L by 2 into x by L gets cancelled, so y is equal to x by 2. Okay, so this is one relationship which we can get from here. Now we'll use an energy method of solving this particular energy problem, vibration problem. So we'll list out all the energies involved in this. First, kinetic energy or potential energy of 2k spring. Okay, so 2k spring potential energy half into k into, depending upon the 2k, it's going to be y square, right? So it's y square. So let's make y as x by 2 and we'll go ahead with it. So this 2 and this 2 will go, k into y is actually x square by 4. so it's gonna be kx square by 4. This is energy of this particular spring over here. Now next is this particular spring, which is energy of k spring. It's not kinetic energy, sorry, it's potential energy. You were supposed to write spring energy. Okay, so this is potential energy of k spring is equal to half k x squared. Okay, so here in this, if we could see, half into k into, now if we could take the particular rope over here, if the center point of this particular bar goes down by the length x, actually the two wires go by a distance 2x. Okay, so since this is 2 wires, so it means that if you take this down, it goes down by the measurement of 2x. So it's gonna be, in the place of x, we're gonna substitute 2x square. So half into k into 4x squared, so which is gonna be 2, so which is 2k x squared. Okay, so 2k x squared. So now next is, we shall solve the next thing, which is kinetic energy, which is formed during to translation. Okay, so we should use, okay, kinetic energy of translation. Okay, so that should be equal to half m into velocity, half m v square, which is x dot square. Let's have it as such. And next is kinetic energy of rotation. So that would be equal to half I theta dot square. Okay, so that would be half into, in place of I we substitute half into mr square. So in place of theta dot, we shall substitute in terms of x, because we already have x. Okay, so what could be done? So now this is a rotational stuff. So since this is rotational stuff, it's gonna be x dot, okay, x dot by r. So v equal to r omega, right? So omega is gonna be v by r. So v is gonna be x dot and r is gonna be the same, x dot by r, the whole square. So this is the thing which they have given over here. So this r square, okay, let's make it simple over here itself. So this r square and this r square will get cancelled, so x dot square. So half and half is 1 by 4. So finally it would be 1 by 4 m dot x dot square. Okay, so now total kinetic energy. So we should, okay, first we shall make it as a total energy. So energy is equal to, so first what we have, 1 by 4 mx dot square, okay, plus 1 by 4 mx dot square, 1 by 2 mx dot square again, 1 by 2 mx dot square again, plus 2k x squared, 2k x squared, then kx squared by 4, kx squared by 4. Okay, so now let us make it even more simpler. So 1 by 4 mx dot square 1 by 2, which is 3 by 4 mx dot square, plus 2kx square plus kx square by 4. So 2 plus 1 by 4, which is 9 by 4 kx square. Okay, so this is very simple mathematics. So now this is the total energy. Okay, now what will we do? Differentiate this energy with respect to time. That will give you 3 by 4 into m into 2x dot into x double dot plus 9 by 4 into k into 2x into x dot. Okay, so once this is done, so we can see that this will be 2, this will be going, this will be 2, and this will be going off. So x dot and x dot will also go off. Okay, so we'll just write the remaining things available. 3mx double dot plus, sorry, 3 by, okay, it's 3 by 4. Okay, this is 9 by 4. Yeah, so obviously it will be 3 by 2 m x dot x double dot plus 9 by 2 k x. Okay, so 9 by 2 kx is gonna be equal to 0. So we have differentiated already. So what will we do? It will be like we should make it into a simple harmonic motion format. So that would be actually x double dot plus 9 by 2 kx. So here it will be 3 into 2, okay, m. So this 3m came over here and 2 went to the top. So 2 gets cancels, 3 and 3 gets cancelled. So simple harmonic motion equation will come like x double dot 3kx by m. So final answer would be, so since this is simple harmonic motion, omega is equal to root of 3k by m. So which is the final and required answer. Okay, so let's check whether in what option we have this. So yeah, root of 3k, root of k by root of 3 root of k by m. So this is the final answer. Thank you.